back to Maths in an Empty Classroom with me, Mr. Southern. This is example 2 of exponential rates of change word problems. I owe a massive debt of gratitude for a former colleague of mine, Mrs. Borland, absolute legend, for letting me use this example in this video. So thank you, Mrs. Borland, you're an absolute hero. So we have the daddy longlegs population inside Mrs. Borland's house. Varies according to this formula here. So n representing the number is 50 minus 30e to the negative 0.2t. And we're going to be asked a series of questions regarding this formula here. So part A, how many daddy longlegs did Mrs. Borland see initially? Right, so initially, that key word at the start when t equals 0. So we substitute t equals 0 into n. So 50 minus 30e to the negative 0.2 times 0. This bit's going to go to 0, which means the e bit, e to the power of 0, is 1. So I have 50 minus 30 lots of 1. So initially we had 20 daddy longlegs there. Now that's important because in the previous example we could say, oh okay, t is 0, it's just that number there. But don't be lazy, think about substituting t equals 0 in, what value you get out of it. In this case it's n equals 20. Okay. Part B, the number of days it would take for the number of daddy longlegs to first exceed 35. Now this is important, exceed, first exceed, doesn't mean equal, exceed is greater than. So when is it first more than 35? When is n greater than 35 for the first time? So I'm not solving this as an equation, I'm solving it as an inequality, and therefore I must use the inequality notation throughout this work. So 50 minus 30e to the power of negative 0.2t has to be greater than 35, has to exceed 35. So firstly, subtract the 50, so I'm going to get negative 30 e to the power of negative 0.2t is going to be greater than 15, negative 15 I should say, sorry. And then I'm going to divide by negative 30. Now negative 15 divided by negative 30 is positive a half. But what is really, really important here is because I'm dividing by a negative, the direction of this inequality symbol is going to change. So it's going to be e to the power of negative 0.2t is going to be less than 1/2. That's very, very important. I've isolated e, which means I can do ln, the inverse function, take ln's of both sides. So I get negative 0.2t is less than ln of 1/2. I'm then going to divide by negative 0.2. So t is going to be greater than ln of 1/2 divided by negative 0.2. Now notice again, I've divided by negative 0.2, so the direction of the inequality has changed. T is greater than this number here. And that should make sense because n is greater than 35, so the daddy longlegs population is increasing, so we expect it to get to 35 after more than a certain number of days, so greater than this number here. So all that's left to do is to say that t is greater than that, so ln of 1/2 divided by negative 0.2, t is greater than 3.46, 5, etc. So the number of days it would take to first exceed, because it's greater than 3.465 and we're asked for the number of days, technically it would be 4 days, so it would be more than 3.465, rounding up to the next integer, more than 4. Just as a quick aside, we've divided by a negative, but we've got a positive answer. What does that tell us about ln of 1/2? It tells us that ln of 1/2 is a negative value, which we knew about because ln 1 is 0, and the ln of a number between 0 and 1 is negative. So that all makes sense here, it's all linking in beautifully. So that's part A and B nailed. I don't need any of that information for the subsequent questions, so I'm going to erase that, just retaining the original formula that I'm going to carry on using. And part C is asking me for the long-term prediction. Now, the long-term prediction is just another way of asking me, what is the asymptote of this function? Well, the asymptote, we talked about this, remember, the e bit cannot be 0. So we say, okay, well, what if the e bit was 0? Well, if it was 0, we'd have 50, take away 30 lots of 0, so it'd be 50. So the asymptote of this function is going to be n equals 50. So how we write that is we say that n is tending to 50. And that might be a little bit clearer when we sketch the function in part D. So let's do that now. And again, we're talking about shape, intercept, and asymptote. Now, the intercept, first of all, with the n axis, this one here, it's going to be our initial value that we found out in part A, so 20. So it's going to be 0, 20. This is our t-axis here. And we've got this asymptote at n equals 50. So that is the long-term prediction. This is the value, n equals 50, is the upper limit of the number of daddy longlegs. Presumably my good friend and colleague Mrs. Borland, once it got to 50 daddy longlegs in her house, she was going to start taking some action. The curve behaves like this. So it approaches the asymptote, but it's this shape of curve here. So it's increasing, but the rate of increase is gradually getting smaller and smaller. So that's what the sketch looks like in part D. Now then, E, it's asking us about rate again, and it even says this time find using dn dt, so differentiating n, but remember that word rate, as soon as you see that word rate, means differentiate. So I'm going to start with n equals 50 minus 30e to the negative 0.2t, and I'm going to differentiate it. Now 50 differentiates to nothing, and to differentiate this e, I'm going to multiply by the number here, the coefficient. So it's going to be negative 0.2 times by negative 30e to the negative 0.2t, because the e bit doesn't change, just multiply by that coefficient. And 0.2 times by 30 is 6, negative times negative is positive, so my expression for dn dt is 6e to the power of negative 0.2t. I'm asked for the rate when t equals 4, so I'm going to substitute t equals 4 into dn dt, which is 6e to the negative 0.2 times by 4. I'm going to find that value, so 6e to the power of negative 0.2 times by 4, which is 2.695, so it's 2.70 to 3 significant figures. And the significance of that, the rate at which the daddy longlegs population is growing, is 2.70 daddy longlegs per day, because t in this question represents the number of days. Right, I'm going to need that bit of information to do part F, which is the last bit, so I'll just clear that. I'll jot down for part F that dn dt equals 6e to the negative 0.2t, and in the final part, part F, I'm being asked for the value of n when dn dt equals 4. So I'm going to make this equal to 4, so 6e to the negative 0.2t equals 4. Divide by 6, I'm going to simplify that to be 2/3. Lund both sides, so negative 0.2t equals ln of 2/3, and I'm then going to divide by the negative 0.2 to say that t is ln of 2/3 divided by negative 0.2. Now, reading the question, I haven't been asked for the value of t, I've been asked for the value of n. So what I need to do now is I need to substitute that number into n. So I'm leaving it as it is. I'm going to say it's 50 minus 30e to the power of negative 0.2 times by ln of 2/3 over negative 0.2. And if I type that into a calculator, it comes out, would you believe, as exactly 30. So do not find this value, round it and then put it in, because then you won't get exactly 30. 30 is the final answer. You must get 30 as the exact value. For anyone that's interested, I'll do in blue. It's rather beautiful why this works, actually. If you look at this bit here, negative 0.2 times by negative 0.2 is going to cancel out. So what you actually end up with is 50 minus 30e. Because the negative 0.2s have cancelled out, I've got ln of 2/3. What do we know about e and ln? They're inverse operations of each other. So these two things here, e and ln, are going to cancel each other out. So what I'm then going to be left with is 50 minus 30 times by 2/3. 2/3 of 30 is 20, and 50 take 20 is 30. Beautiful exact answer. Personally, I find that deeply satisfying. Thanks very much for watching. See you again.